Somewhere out there, quietly following Earth around the sun, there's a rock that scientists thought they'd already solved. In 2021, they believed they'd proven it was a piece of our own moon. But this year, a spacecraft finally got close enough to check. And instead of confirming the theory, it blew a hole straight through it. By the end of this video, you'll know exactly why. And why the real answer might not arrive until 2027. This is the story of Kamoʻoalewa and the Tianwen-2 mission. To understand this rock, you first need to understand what it actually is. Kamoʻoalewa is a quasi-satellite, one of only 7 known objects that loop near Earth without technically orbiting it, caught in a strange, semi-stable dance. It's been following this path for centuries, unseen until very recently. It's a cosmic companion that shares our yearly journey. It was discovered in 2016 by a telescope in Hawaii, and almost immediately it stood out. The discovery came from Pan-STARRS, a telescope system on a Hawaiian summit built to scan the sky for exactly this kind of object: small, faint, and easy to miss. In 2021, researchers compared Kamoʻoalewa's light signature to real lunar rock brought back by the Apollo missions. And it matched closely enough that scientists proposed something extraordinary. This wasn't just an asteroid, it was part of us. It might be a chunk of the moon itself, blasted into space by an ancient impact and quietly drifting alongside Earth ever since. Testing that theory meant getting a spacecraft close enough to look. That's what China's Tianwen-2 mission set out to do. Tianwen-2 is part of a new wave of asteroid missions, alongside Japan's Hayabusa 2 and NASA's OSIRIS-REx. Tianwen-2 launched in May 2025 and spent 400 days traveling more than 1 billion kilometers to its target. On July 2nd this year, Tianwen-2 closed to within 20 kilometers of Kamoʻoalewa and captured the first close-up photograph. It was the most detailed image ever taken of this object, and that photo immediately raised a massive problem for the theory. Ground-based telescopes had estimated Kamoʻoalewa's size at somewhere between 40 and 100 meters across. This was the baseline. Tianwen-2's actual measurement came back at just over 20 meters, less than half of the smallest previous estimate. That's not a small correction. That's the kind of gap that makes scientists question the assumptions of the entire lunar origin theory. A study released just weeks before Tianwen-2's arrival proposed something different entirely: an origin in the asteroid belt. It suggested Kamoʻoalewa's composition is a closer match to LL chondrite meteorites, likely from the Flora family. Not our moon. Photographs and distant estimates can't settle this, the same uncertainty that led to years of guessing its size incorrectly. There's only one way to know for certain. Tianwen-2 will close in further to just 300 meters for a sample collection. The mission will return that material to Earth in 2027, where it can finally be tested directly against real lunar rock. Until then, Kamoʻoalewa keeps its secret. It could be a literal piece of the moon or a completely unrelated visitor. We won't know for certain until that sample comes home. If you want to be there when it does, subscribe to Orbit Report.